Hello everyone, welcome back to my channel. So I'm back with another video on half wave rectifier. Now most of the electronics device work on DC source, but our domestic supply is AC in nature. So it is very important to convert that AC supply into DC for the proper operation of these devices. So this is the block diagram we use for that conversion. That is, if we get AC supply 220 volt AC supply here, so here we need a regulated DC supply. Now how each of these blocks work, we will discuss in brief about it, but our main focus is to discuss about rectifier. So here, what is the function of transformer? It steps down the voltage. Now step down means our input is 220 volt supply, but do every device need the same voltage? No. Some require 15 volt, some work on 12 volt. Steps down the voltage from 220 volt to the desired level, say 12 volt. Now this is AC only. Transformer does not change the nature of the supply. It will convert only the level of the voltage. Now rectifier, we will discuss about it in detail, but for now it converts AC into pulsating DC. Now pulsating DC means a waveform which contains both AC and DC. And further, as I told you that we need a regulated DC. So pulsating DC is not the output we need from this block diagram. Okay, so further we use filter that lowers down the ripple, and we get a not exactly regulated, but we get a near to regulated DC supply. And finally we use regulator to get a regulated DC. Now we can see the waveform each block gives us. Like here, if the input is taken as an AC 220 volt, so it will lower down. The type will be same, but the DC level will be different here. Rectifier will convert AC into pulsating DC. So it will be DC, that is unidirection, but it will have some AC component also. Filter will convert it into DC, but this is not a ripple free DC, but it has some ripple. And finally we get a regulated DC at the output of the regulator. Talking about rectifier, it is a device which converts AC input to pulsating DC. So pulsating DC means AC plus DC. That is a DC which has some AC component in it. What does it mean to have AC component? We saw the output of the rectifier was this, or it could be even this. We can see that still this is a pulse, only a positive half pulse. It is still varying with time, but DC voltage does not vary with time. So that's why we call it a AC. And DC means these waves can be seen only in the positive direction. That's why these are called to be DC in nature also. Now the first point is clear. Now second, it offers low resistance to current in one direction and high resistance to opposite direction. So we can see the input was this. Here both positive and negative cycle was present, but at the output only positive cycles are present. So this means it is blocking the negative half of the cycle. So from that we can conclude that it offers resistance in one direction but a free flow of current in the opposite direction. Now third, the output contains both AC and DC component, as we have already discussed. Now I have shown you two types of waveform here, 1 and 2. A rectifier can be divided into two types, half wave rectifier and full wave rectifier. Half wave means only positive cycle is seen, negative cycle is completely eliminated. But a full wave rectifier is one in which a negative cycle is also converted into positive cycle. So it is a full wave rectifier. But here we will discuss only about half wave rectifier. I'll make a separate video on full wave rectifier. This is the circuit For half wave rectifier, we can see a AC supply here, a transformer here. This is diode with P and N type connected in this way, and finally the load. This is how AC supply looks like, positive, negative. Now when a positive cycle is applied, so positive, negative, a transformer will only step down the voltage. It will not change the terminals. So here also we'll get a positive and negative. So we can see that P is connected to the positive terminal. I've already discussed about diode in our earlier videos, so here I'll not go in detail. Here if P terminal is connected to positive side, so here this diode will act as a closed switch and current will easily flow through the load, and what we get in the positive half, we get a cycle like this. When negative is applied, then P is connected to negative terminal and it will act as a open switch. When the circuit is open, no current will flow and we get nothing in the negative half cycle. Similarly, for every positive and negative half cycle, this is the final waveform we get at the output of the rectifier. We have already talked about the input and output waveform of rectifier. Input has both positive and negative cycle, but when we come to the output, what we get? We only get positive half cycle. Now there are few parameters which actually define the performance of the rectifier, half wave rectifier. So we will discuss it one by one. First is DC voltage. As we have already seen that the output waveform of rectifier contains both AC and DC components. So here this is the DC voltage or DC current. So this is defined as 1 by T, 0 to T, V input of T, where V input is, this is how the AC waveform is defined. So when we substitute value of V in here, for half wave rectifier we get Vm by pi or Im by pi. This is RMS component, which is the AC component. So Vrms is given by 1 by T, 0 to T, V in square of T. So this we get as Vm by 2 or Im by 2. Third is efficiency. When we talk about rectifier, what is the output of rectifier? A pulsating DC. But what is actually the desired output? Only the DC. So efficiency means how much DC component is present in the output of the rectifier. Efficiency is defined as output DC power, input AC power, and it is given as 40.6%. It gives us the percent of AC input converted to DC. If AC input is considered as 100, then the only 40.6 of that 100 is converted to DC. That means around 60% is still AC. So this is not desirable. Next comes ripple factor. Ripple means the AC, again ripple or pulsating or fluctuating. These all words define the AC component of any waveform. So ripple factor means the AC component in the output waveform. So this is given as ripple component to DC component, and it is given as RMS at the output, DC at the output. Look, efficiency was defined for power, but ripple factor is defined for voltage. So this is the difference, and this comes out to be 1.21. It means AC present is 121% of DC voltage. Means in the output waveform, 121% of DC voltage is AC. Obviously, which is more than 100%. Again, this is not desirable. Ripple frequency. It is the frequency of the rippled component of the waveform, output waveform. It is same as the frequency of the input waveform. Form factor is defined as RMS component at the input to DC at the output, and it comes out to be 1.57. Transformer utilization factor. It tells about the characteristic of a transformer which we are using in the rectifier circuit. So before talking about TUF, Actually, what is the function of the transformer? It steps down the voltage, that is, it converts the AC input voltage to desired level as per the required application. Also, it provides isolation between AC mains and rectifier input. We can see that rectifier input is not directly connected to the AC main, so this means it is also providing isolation. It is given by DC output power VA rating of transformer at secondary side, and this comes out to be 0.286, which is again it is very low. To better understand it, say VA rating is 1 kVA, which is 1000 VA, then only 286 watt is delivered to load, which is very low value. Finally, peak inverse voltage. When a diode is reverse biased, it should be operated under controlled level of voltage, because there is a maximum voltage above which it may get damaged. So we must know about that maximum voltage. So that maximum voltage in the reverse biasing that a diode can withstand without destroying the junction is called PIV, and PIV for half wave rectifier is VM, where VM, so this is the maximum peak voltage of the AC waveform. So now I have consolidated all those important performance parameter in a table, and these are the generalized value for these parameters. Go through them once. Finally, the disadvantage, as we saw that only a half cycle is allowed, other half cycle is wasted, so this means power is wasted in the half wave rectifier. Ripple factor was high, efficiency was low, and transformer utilization factor is also low. So because of all these disadvantages, half wave rectifier is generally not preferred. Hope you understand this video. If you do, please like and subscribe. Thank you so much. Bye and take care.